Hello, welcome to A2 6.4 Trigonometric Identities. So we've already in AS met trig identities, and two should immediately pop into your mind. Um, have a think if you know what they are. Um, you should be thinking that tan theta equals sine theta over cos theta. So that's one of the trigonometric identities that you should be in your common knowledge from AS. And the second is sine squared theta plus cos squared theta equals 1. So you have two identities which you know, and these aren't in your formula books. So as I often say to students, you have a formula book, and I would be suggesting that you write these perhaps the front cover on those back pages, so that you've got all these other things you need to know somewhere. So today we're going to learn some more trigonometric identities. And again, these are not in your formula book, so there's something you have to learn. So again, yes, you've got to learn it before you walk into that exam, or immediately there are questions you aren't going to be able to answer. And we actually find these trigonometric identities by using this identity here. So if I first of all, for the first one, I take sine squared theta plus cos squared theta equals 1. And I'm going to divide every term by cos squared theta. So here we go. So every term has now been divided by cos squared theta, and sine squared theta over cos squared theta, well, that would now be tan squared theta. And cos squared theta over cos squared theta, well, that would be 1. Now we've just learnt about 1 divided by cos theta, and we know 1 divided by cos theta is sec theta. So this is sec squared theta. So if maybe you've forgotten those other trig functions, I'm just writing them down here so you can look back at them. So here now I have my sec theta, cosec theta, cot theta, which we've recently learnt about. And here is a new identity, which, as I said before, you have to learn. And you now have an identity that links sec squared theta and tan squared theta. So that's identity number 1. So identity number 2, so these you need to learn. So notice everything that's in a box is information you are going to need to learn. And we've taken this identity from our AS and we've divided it all by cos squared theta. So we can now go through, repeat, but divide it all by sine squared theta. So here, sine squared theta divided by sine squared theta, that's 1. Now, cos over sine, because sine over cos is tan. So this is cos over sine, so it's the reciprocal of tan. And the reciprocal of tan is cot. So this here is cot squared theta. And this here is cosec squared theta. So I now have another identity. So there we go. 2 new identities for us to use when we're solving trigonometric equations. So if you haven't already, write those down. Press pause, get them written down, and we're now going to go on and we're going to look at using them. So here, prove that cosec theta to the power of 4 minus cot theta to the power of 4 equals 1 plus cos squared theta over 1 minus cos squared x. Now, immediately, I think something's got a bit wrong there. That shouldn't be an x, it should be a theta. So we need to sort that out. So now, looking at this, here I have something to the power of 4, and actually all of my identities that I know are all about squareds if we think back. So I would like to somehow factorize this, and what I do notice is that this is actually the difference of two squares. And you do need to get rather good at spotting the difference of two squares. So here, this would be the same as cosec squared theta minus cot squared theta, and this would be the same as cosec squared theta plus cot squared theta. Now, if you're looking at that and thinking, my goodness, how have I managed to do that? Let's just revise a bit of late GCSE, early A level. If I do x squared minus y squared, that's x plus y, x minus y. That is the difference of two squares. You should have that solidly in your mind, though many don't. So if you haven't, don't feel, oh, I can't do it. But then you need to put a poster in your room, do something, write it on the front of your maths book so that you become aware of that is the difference of two squares. So if I now change this and I make this to the power of 4, I can do then this, because of when I expand this, you'll notice that my x, y terms, one is negative, one is positive. So when you put them together, they come to 0. Equally here, my x squared, y squared terms will again come together to make 0. So I'd be only left with x to the power 4, subtract y to the power 4, which is how I get to this. So having got here, I do now have something with squares in, which is rather handy because actually that's how my identities work. So let's write those identities out on our page that we've worked out previously on the last page. So they are our identities which we can just write down that we're using. Now, if you notice, this one here, I could rearrange and write 1 equals cosec squared theta minus cot squared theta, which is actually this bit here. So therefore, because I have this here, the examiner can clearly see what I'm up to. I've written that. I've now said, well, I know that 1 equals that. I now can come over here and go, well, that's 1 times, that dot, by the way, is in a decimal point, it's multiplying cosec squared theta add cot squared theta. So it's just that. That's what I'm left with. So that's actually got rid of one bracket quite nice and easily. Now, I now want to look at this because when you're doing a trigonometric identity, and it's the same at AS, have a look at the answer to give you a clue of where to go. These here, this is cosec and cot. This is in terms of cos. So I'm going to need to put these in terms of sine and cos. So cosec is becoming 1 over sine squared theta, and cot would be cos squared theta over sine squared theta. I've got a common denominator, so now this is going to help me pull this together as one fraction. Now, looking back at this point here to my answer that I'm trying to get to, I'm trying to prove this. Look, my numerator is the same. Brilliant. Now what I need to do is get that denominator sorted out. Well, I know for the denominator that sine squared theta plus cos squared theta equals 1. So sine squared theta equals 1 minus cos squared theta. Now, really is important, which equals right-hand side. So we've proved it. It's really, really important that you make it clear how you've got all the way through this because it's a proof. They've given you the start, they've given you the end. What students try to do is just, if they're not too sure, just kind of just make it up a bit and then let it appear. Yeah, there's clear rules about that that are written on the mark scheme. And this can then affect those people who do too much in their head and don't write workings, because if you don't write enough stages and the examiner can't see it, they won't give you the marks. So please don't miss things out. You've got to realise the question and the answer there. You've got to show that you've clearly worked through it. That's example one. Look at it, perhaps have a go and go back to the beginning of the video, you have a go and press play through it when you need some help, because that's a really good way to learn. Once you've done that, got it copied down, etc., watch example 2. So this is example 2 now. So again, I'm going to start, before I get going, I'm going to write down my identities. So there's my identities and there's my equation. So this is looking like it wants to be a quadratic because I have one term that's squared and another term that isn't squared. Therefore, what I'm going to need to do is make sure these are both cosec or both cot or something like that. So I'm looking over here. I can't change that because it's not squared. It's easier for me to change this term. So this cosec squared theta, I can change to a cot, which does make my life a lot easier. So I'm just going to use this. So I can do 4 lots of 1 plus cot squared theta, subtract 9 equals cot theta. So 4 plus 4 cot squared theta, subtract 9 equals cot theta. 4 cot squared theta, subtract cot theta, subtract 5 equals 0. So now need to factorise that. The good news is you do have your calculators, but if not, you'll have to do it in your head. And it's going to be negative, so it would be like that. So from here, we then can go that cot theta equals 5 over 4, and cot theta equals -1. And remember that cot theta is the reciprocal of tan theta. So tan theta is 4/5, and tan theta equals -1, because the reciprocal of 5/4 is 4/5, and the reciprocal of -1 is -1. So now calculating the values of those, you do need to remember that at this point, usually in the A-level syllabus, you've just done radians. So make sure your calculator is in the correct settings, because this question is in degrees. And you will find that here, theta would equal 38.66 degrees. I'm doing it to 2dp at the moment. And here, theta is equal to -45. Now, the tan graph is beautiful because what you find is it repeats every 180. So here we go. Let's dot that down, then like that, dot it down again, and like that. That's 360, that's 180, that's 0. So if I look at 38.6, that would be there. Where does it happen again? It happens 180 there later. So the next value would be 38.66. Add that 180, which would be at 218.66. And then here, well, we've got negative 45 degrees. It's between 0 and 360. So 180 on, that would be that point there. So 180 onto that would be 135 degrees. And then 180 on again. From there, that would be 315 degrees. So the final answer brings all of that together. I'm only going to go to 1dp though at this point. I write them in order. Let me just move that up a bit, or perhaps the camera down a little bit. So 218.7 and 315 degrees. There we go. So there we go, and they are my 4 answers for the solving of that equation. Right, that's it. Now practice some.